Here are a few more homework questions from chapter number 6. And for these problems, we're given the derivative, and the derivative is taking the form of an equation here. And our goal is that we need to find the original function. And we're also given an initial condition over here on the side in the green box there, and that should help us find the constant, because when we take the antiderivative, we're always given a constant. And over here on the side, I do have another formula here, which I'll be using later on in the problem. Okay, so if I'm given the derivative, and if I want to go back to the original function, I need to take the antiderivative. So what do I do with this power? This 6 right here, which is a constant, that would remain. And then take a look at this variable right here, x squared. The power is 2, so I need to add 1 to that power. So that's x to the power of 2 plus 1. And then I divide by the new power, which is going to be 3, minus 2. And then we have a single x here, so that's really x to the power 1. So I take that power 1 and add 1. And then I divide by the new power, which is going to be 2. And then finally over here I have plus 1 over x, and if I use my reference sheet over here, my formula there, the antiderivative of 1 over x is ln x plus c. So now I have plus ln x, absolute value of x, plus c. And then from there, let's go ahead and simplify this. 6 divided by 3 is going to be 2, so this is going to be 2x to the power of 3 minus, and then 2 divided by 2 is 1, so this would be negative x to the power of 2 plus ln of absolute value of x plus c. All right, and then we're going to use our initial condition here. So back to my green box here, I know that f of 1 equals to 4. So I take this 4 now. This 4 would come over here. So that's going to be a 4. Let me just write this as f of x. Okay, and then I'll use the f of 1 equals to 4. So what that means is f of x now becomes 4. And then after that, anytime you see an x value, the x values, they just change to a value of 1 now. And that will allow me to find the value of c. Right, so in order to do that, this would be 2 times, to the power of, there's now 1 here, minus, bracket squared, and then I'll put another 1 here, and then plus ln the absolute value of 1 plus c. So let me just kind of clear all this up here now. Let me just clear all of this. There's a lot of colors here, I apologize. So what I'm just trying to emphasize here is this initial condition. Once you apply that 4 over here and the 1s here, that will allow you to find the value of c at the very end. Okay, let's continue and solve this now. So this will be 4 equals to 2 minus 1 plus, now ln of 1 is just going to be 0, and then plus c. All right, and then now you need to find the value of c here. This is going to be 4 equals to, well, 2 minus 1 is going to be 1 plus c, and c has a value of 3. Okay, so in order to kind of finish off this problem now is I need to go back to f of x. Let me just erase all this now. So we did all that work and we found that c was equal to 3. So all I have to do now is I need to change that value of c to 3 now. So change that to a 3, and this is your original function. Okay, so that's it for that particular problem. Let's do a few more and then we'll finish this. I'm now moving on to the next question, and for the next question I'm given f prime of x, and the goal is I want to go back and find the original equation. And if I want to find the original equation, I need to find the antiderivative. And when I'm finding the antiderivative, let's just look at each term separately here. So my first term is going to be e to the power negative x. And for that, I can just go down to one of my formulas down here. So if I have e to the power negative x, remember the k value here is going to be negative 1. So that's going to be, if I use the formula correctly here, it's going to be 1 over negative 1, e to the power negative x plus c. And this part right here, 1 over negative 1, that's just going to be negative 1. So that's just negative e to the negative x. All right, so that's my first antiderivative. So I can write down negative e to the negative x. And then after that, if I take a look at my second term here, this fraction here, that looks very similar to this first formula here, and the antiderivative of 1 over x squared plus 1 is the inverse tan function, so I can write down plus inverse tan, and that takes care of that one. And then for the next one here, I have minus 3 times sine x, so I can write down minus 3 for the constant. And then for sine x, I had the formula right here, so the antiderivative of sine x is going to be negative cos x. So bracket negative cos x. And then finally, I need to have a plus c at the very end there. Okay, and then what we can do next is, let's just clean this up here. So this will be a negative e to the negative x plus tan inverse of x. And then I have a minus and a minus, so that's going to be plus. So plus 3 cos x plus c. Okay, so that's my antiderivative there. Let me just erase all this. And finally, in order for me to find the value c here, I need to take a look at this initial condition right here. F of 0 is 2. So that means if I take this 2, that will replace the f of x now. So 2 equals 2. And then anytime I see an x, all the x's will now change with 0. So now I have negative e to the power of negative 0 plus tan inverse of 0 plus 3 cos of 0 plus c. All right, and now let's go ahead and solve for c here. So this is going to be 2. This part right here is going to be just 1. So this will be negative 1 plus. Now the inverse of tan at 0 is going to be 0 plus. And at cos of 0, that's going to be 1, so 3 times 1 is going to be 3. So if you weren't sure how to evaluate these numbers here, make sure you look at your graphs, and that should help find those values. And then we can have our plus c at the very end there. And then if I execute this, I have 2 equals 2. Well, negative 1 plus 3 is going to be 2 plus c, and that means c equals to 0. So finally, if c equals to 0, my final answer will be f of x equals to negative e to the power of negative x plus the inverse of tan plus 3 cos x. And that is my final answer there. Okay, let's move on to the last question in this video homework guide. Okay, for this very last question, this time I'm given the second derivative, and the goal is I want to find the first derivative, so that means I need to find the antiderivative 2 times. All right, so if I apply the antiderivative once, I will go back to the first derivative, right? And what's the antiderivative of e to the power of negative x? Well, we kind of did this already in the previous problem, but I'll do it one more time over here, e to the power of negative x. And if I follow the formula here, it's going to be 1 over k, so 1 over negative 1 e to the power of negative x. So this right here is just going to be negative e to the power of negative x. So that's my first antiderivative, so negative e to the power of negative x plus 6x. So the power on the x is just a 1 right now, so 6x to the power of 1. And then I need to add a 1 to that, and then divide by 2, and then I need my plus c there. And then let's just simplify this. So this will be negative e to the negative x. And then I have a 6 and a 2, so 6 divided by 2 is going to be 3, so plus 3x squared plus c. And this right here is my first derivative. All right, so after that, I need to take the antiderivative one more time to get back to the original function. And if I do that, I know that the antiderivative of that expression right there is going to be negative e to the negative x. And then this minus 1, this other minus sign just tags along. So the two negative signs, they'll just cancel each other out and just give you a positive value. So that's just going to be e to the power of negative x. Plus, now I have a constant here, so the constant can remain. And then the power here is a 2, and then we just add a 1 to that. And then my new power is going to be a 3, so I need to divide by 3 plus. Now the antiderivative of a constant is going to be cx, and then I need to add another constant because I'm taking the antiderivative. Okay, so y equals 2. Let's just clean this up now. E to the negative x. And we can see that the 3's and the 3's, they will cancel off. So this will be now plus x to the power 3 plus cx plus d. All right, so that's your original question there. And what you need to do now is you need to find the values of c and d by using your initial conditions. Okay, so I'm going to rewrite the initial conditions over here on the side. The initial conditions were f of 0 equals to 2. And the other initial condition was f of 1 equals to 1 over e minus 1. So those were my two initial conditions. Let's go ahead and use the very first initial condition here, f of 0 equals to 2. So what that means is this y value here, the y value there will now change to a 2 equals to e to the power negative 0 plus 0 to the power 3 plus c times 0 plus d. Okay, and if I keep on going here, this will be 2 equals 2. Well, anything the power of 0 is going to be 1 plus 0 plus 0 plus d. And if you solve for that, d will now equal to 1. So d equals to 1 for that particular equation there. Okay, after that I'm going to erase this, and we're actually done with the very first initial condition, so I can erase that guy there. And after that, let's go ahead and use this second initial condition here, where f of 1 equals to 1 over e minus 1. Okay, so for this particular part, I can take the 1 over e minus 1 and replace that with the y now. So now I have 1 over e minus 1 equals to e to the power of negative 1 plus 1 to the power 3 plus c times 1 plus d. Okay, so now I have 1 over e minus 1 equals 2. Now this part right here, you might as well just turn that into its reciprocal form. That's going to be 1 over e plus 1 plus c plus, now for d here, we know that the value of d is going to be 1, so let's just plug in the 1 right away there. And let me just erase this because I need a little bit more space. And then let's go ahead and solve for our c variable now. All right, if I do that, I can see that the 1 over e's, they just cancel off. And if I look at this, this is plus 1, that's going to be 2. And if I bring 2 to the other side combined with a negative 1, that's going to give me negative 3. So negative 3 equals to c. And remember, d equals to 1. Okay, so if I just erase all this now, let's just go ahead and write out our final answer here. I have y equals to e to the negative x plus x to the power 3 plus c. C was negative 3, so I can write that as negative 3x plus 1. And that right there is going to be my final answer once I've inserted everything back into the original problem. All right, so that concludes this video homework guide.